Today we're going to talk about orbitals, energy level diagrams, and electron configurations. And all of this should be a review of what we've done in class with the boarding house model, but I just wanted to go over it one more time just to make sure all the rules were very clear. So while you're watching this, you should be filling in sections 4.7 and 4.8 in your notes. Now, if you remember from the video you watched on Educanon last week, atomic orbitals are regions of space where an electron is likely to be found. And so we sometimes refer to these as probability clouds, but the orbital itself is the 95% probability that that's where we'll find the electron. If you remember, the probability gets smaller as we go away from the nucleus, but it never falls completely to zero. So if we try to do an orbital that was 100% of the probability cloud, then there's a chance that it could be anywhere in space. So we choose 95%, and then that gives us these different shapes for the probabilities for where the electron is going to be found. So the s orbitals are always this spherical shape or the shape of a ball, and the p orbitals, there are 3 of them, but they all have the same shape. They're all this dumbbell shape that's shown here, and then they're oriented in different directions in space. Okay, so the difference between a probability cloud and an atomic orbital is that the probability cloud is 100% of the probability, whereas an orbital is only 95%. And if you remember from class, we can have 2 electrons stored in each of the atomic orbitals. All right. We can show where these electrons are located in their orbitals using an energy level diagram. So an energy level diagram depicts the energy levels in an atom and shows where the electrons are located, which orbitals they're in, which sublevels, using arrows. All right, so if we take nitrogen as an example, nitrogen has 7 electrons, which we can get from the periodic table. We know that if it has 7 protons, that also means it has 7 electrons if it's neutral. Okay, so in the first energy level, we have 1s, and it has 2. All right, and now once we've filled up the first energy level, we can go up to the second one. And we know that we filled 2s first, so that's 2 more, so that makes 4. 2p is a little bit higher, and there are 3 orbitals in the 2p sublevel. Okay, so we have 3 more electrons left, and if you remember from class, our rule is that we put 1 in each orbital before we put 2 in any in a given sublevel, and that if you put the first one in up, then the other 2 have to go in up as well. All right, so if we had put the first one in down, then the other 2 would have had to go down, but they all 3 have to have the same spin. Okay, so then that gives us 7 electrons total. So this is the energy level diagram for nitrogen. All right, and if we'd had more electrons, we would have then gone up to the 3s once we filled up the 2p. And then we can summarize this using the electron configuration. And an electron configuration just summarizes the arrangement of the electrons in the orbitals. So for this one, we would have 1s2, 2s2, and then we have 3 in our 2p, so it would be 2p with a little 3 up here. Okay, and that would be our electron configuration for nitrogen. Okay, now it turns out that we're most interested in what's happening in the outermost shell of a particular atom. So for the case of nitrogen, what we're most interested in is what's happening in the second energy level. So in terms of the boarding house model, this would be what's happening on the second floor, right? Because the first floor is completely full and the second floor has some people in it, but it's not completely full. So that's where things are going to happen. People are going to come and go on that second floor. So in the same way with nitrogen, because the outermost shell is the second one, that's going to be where the electrons are going to be coming and going when bonding happens and reactivity and all of that sort of thing. All right, and then the noble gas shell is what is inside. So the noble gas shell for nitrogen would just be the full first energy level, which is just 2 electrons. And so if you look at your periodic table, the noble gas that has just 2 electrons is helium. Okay, and what you're going to find is a noble gas is always going to correspond to a completely full shell. And so we're going to call that the noble gas shell, or I'll often refer to it as the core electrons. It's what's in the middle. Okay, and so we can summarize what's happening using a noble gas configuration. And so for nitrogen, we've already done the electron configuration on the other page. And so if we summarize the middle part with the noble gas configuration, what you're going to get is helium, and we write that in brackets like this, and then just what is in the second energy level. So that's going to be 2s2, 2p3. Okay, so when we write the noble gas configuration, what we're doing is we're summarizing the core or the noble gas shell just using the name of the noble gas that has that many electrons. All right, and we're going to practice this in class tomorrow because it doesn't really make sense until you do a few examples, but this is just an introduction, and we'll continue to talk about it more in class.